Okay, best of luck to our final team.
Should I start?
Yeah, go ahead.
Okay. Hi, I'm Moinuddin Ashrafi. I'm from Bangladesh and welcome to our presentation. We are on the behalf of License Academy who asked us to create a solution to reduce carbon emissions in agricultural transportations. We know that agricultural transportation is emitting about 3 tons of CO2 emissions is done by the agricultural transportation, which constitutes up to one-fifth of the total agricultural pollution. The agricultural pollution, transportation pollution is mostly done by trucks, tractors, ships, and sometimes even planes. Here is the problem with this type of vehicles. Currently, we don't have any viable alternatives. EVs cannot replace trucks because of the battery to weight ratio paradox. Hydrogens are very hard to store, and the nuclear power is totally incompatible with vehicles. So, what could be the unrivaled solution to the problem? Ladies and gentlemen, let me introduce you to the synthetic fuel, the art of making fuel from thin air, quite literally. The concept of synthetic fuel is very simple. Vehicles emit carbon dioxide when they burn fuel. What we are going to do is capture that CO2 and turn it into a fuel. When the fuel is burnt again, we get a net neutral carbon emission in the broader spectrum. The process we are considering is DAC or direct air capture method to capture the CO2 and then Fischer-Tropsch process in order to turn it into fuel. It starts by capturing the atmospheric air and we're scrubbing the and where to extract the CO2. Then with the help of water, synthetic fuel is prepared via a series of chemical reactions. One of the greatest benefits of this fuel is that we can turn it into almost any fuel we like, such as methane, octane, kerosene, dimethyl ether, in short DME, which is an alternative to the diesel. And for cost and feasibility, since diesel is mostly used in, we are considering DME or dimethyl ether, since diesel is the mostly used in the heavy transport vehicles. As you can see, the process is you are using cost as from 94 to 232 USD to capture the 1 ton of CO2. Minimum amount of DME which can be produced from it is about 125,000 liters, which gives us a selling price of about 150,000 US dollar. Now, it has to be notified that it is just a rough calculations. For further research and laboratory tests are to be done to get the actual figures. The advantages of synthetic fuel are plenty to say the least. As we have discussed before, it is net neutral, so with no parasitic emissions. Unlike the alternatives we have discussed before, synthetic fuel will not need any major structural change. For example, for EVs, we need to change all the trucks and vehicles running on the road with EVs. Then we need to turn the gas stations into charging stations. Then we need to produce the extra amount of electricity that we need, requiring extra construction of the power plants. In short, you have to change the whole system. On the other hand, for synthetic fuel, you just need to produce the fuel and supply it to the gas stations. That's all. Here, there is no extra complexity. Again, if we take the example of EVs, even if we generate electricity from the renewable resources, the CO2 emissions due to the lithium mining is still unsolved. Lastly, we won't have to solve the emission. It will not only solve the emissions problem in agricultural transportation, but the transportation sector as a whole, and also that of the electricity generation industry. Synthetic fuel might just be the one size fits all solutions that will solve all the CO2 problems. It could be the Superman of our dying world. It has the potential to be our present and our future. Thanks for listening to us. If you have any questions, please feel free to ask.
Thank you so much for your presentation. You can go ahead and stop sharing your screen. I'm just going to give 30 seconds for the judges to wrap their thoughts.
Thanks so much for that presentation. It's creating a synthetic fuel is very, very ambitious. Can you tell me again, what would that synthetic fuel be made out of? And where would the raw materials come from?
Yeah. So the raw material is basically, we need, can I share my screen? That would be actually better. So, can you see my screen? Oh, so here is like the whole chemical formula that is going to be that we are going to follow. So most of the basically what we are going to need constantly is, at first we are turning the CO2 into the fuel. So we need this supply of CO2, which is we get from the air. And another thing we are only going to need is water, more specifically distilled water. And other than that, the calcium hydroxide, calcium carbonate, and all the calcium, potassium carbonate, these are like recyclable. Calcium hydroxide, these are like recyclable chemicals. So once we have that, we can recycle it and use it again.
Is it possible then what you're saying is that you can actually pull carbon dioxide out of the air, or use from carbon dioxide capture systems to then make this synthetic
It has
fuel?
all, yes, it has actually already been done. Yeah, it has actually already been done by Carbon Engineering. It is a company that has been funded by Bill Gates, and a group of Harvard researchers from Harvard University has actually created this method, this DSC, and the Fischer-Tropper process. This process, carbon monoxide plus 3H2 brings methane and water. That is actually Fischer-Tropper process that has been patented by Fischer-Tropsch in, I think, in the 20th century.
You mentioned a cost of 150,000 as a total cost, and I'm curious, but you didn't mention what unit you're using for that. So is that selling price per liter, which seems like a lot, or like is it per 1,000 liters? How does it, or is it per ton of CO2? If you were to sell that, how much would that actually be if you simplified it per liter?
Okay. So per liter, to capture 1 ton of CO2, there we need the cost of capturing 1 ton of CO2 is 94 to 232 US dollar. And like there is something, the calculations I have done is basically, there is a scientific in a chemical formulas, what we use is mole. So when you are talking about dimethyl ether, here you can see it is a 2 mole carbon compound, and carbon dioxide is 1 mole carbon compound. So when you are talking about like carbon dioxide, and in the chemical reaction, it doesn't actually go with the ton or like weight of kilogram, gram anymore. It goes with the reaction with mole. So when you are this calculation has been done with the mole number. So from this mole number, there is a chemical formula in which you can again convert the mole number of the molecules in again to liter or to weight. So that in that way we have done the calculations.
Okay, so just following up with Mr. Charles' question. Now, you looked into License Academy and you looked into this model. How feasible do you think that is for the particular company that you're trying to address the problem?
So can you please repeat the
feasible? So you are trying to solve the problem for License Academy, right?
Yes.
Right. So the solution that I've given, and
yes,
think about their operation structures and everything. How feasible do you think your solutions are for them?
Well, when we at first proposed this, when they at first proposed the problem, they said it could be anything that can be even researched of, and that has actually a bright future, or like a viable future. So in that, considering that proposal of theirs, we have actually persuaded this. And yes, it is actually an ambitious project, and it might need a cost of a lot of money. But if it is like, we can make a model structure, if the team license can make a model's working structure like a prototype, then I think it may get fundings to further build the project.
So our idea basically was to open a new field of research. Obviously, it would need a little more investment and more research, but basically, in India and Bangladesh, a lot of the EV introduction is being very slow because the population still prefers and is more accustomed to fossil fuel automobiles. So to be implemented in a company like License Academy, it would need a little more investment and more research, but it's a new door to follow.